Good morning, everyone, and thank you for joining us. Welcome to our webinar. Today, we'll be talking about integrated security for software development and advanced penetration testing. A pretty long title, so I'll say it again. Integrated security for software development and advanced penetration testing. I was very happy to see we had registrations from all over the Caribbean. So apart from Jamaica, we're saying good morning to our attendees in Barbados, in St. Kitts and Nevis, and in Trinidad. If you are here with us from another island and I haven't mentioned that, please say good morning in the chat. We'd love to hear from you. I am Cora Jane Jude Grant, and I will be your host this morning. I'm Business Development Director here at Symptai. And before we begin, I'd love to tell you a little bit about who Symptai is. So we are a leading cyber and information security firm. We are also dominating in the space of data privacy and protection, digital transformation, and anti-money laundering. In the Caribbean, we have an office in Kingston, Jamaica, and we provide services to all industries from oil and natural gas companies in Trinidad to banks and insurance companies here in Jamaica. We operate on 5 core values, which really fuels everything we do from day to day. And those are integrity, candor, curiosity is a big one for us, extraordinary people, and exceptional results. This year in particular, we're very proud and happy to be celebrating 25 years because we were founded in 1998. So we are still in celebratory mode. I'd love to introduce to you our speaker this morning. His name is Rory Ebanks. He is a director as well here at Symptai Consulting. He is director of cybersecurity and has over 13 years experience in information security and IT audit. He performs risk management assessments to align with information security programs and defines, implements, and manages IT security governance processes. Here at Symptai, Rory is a leader. He executes training opportunities, guides IT security members, and he's earned a Master's of Science degree in cybersecurity from EC Council University and a Bachelor's of Science in Computing and Information Technology from the University of Technology here in Jamaica. Rory has numerous certifications, which are here on the screen, but let me mention a few. He is Certified Chief Information Security Officer, Computer Hacking Forensic Investigator, Certified Network Defender, Certified Information Security Manager, and he's also Certified Information System Security Professional. I know, and I am very confident that you're going to find his presentation very insightful. Before I hand over to Rory, there is a Q&A section. I invite you not to hold your questions. Please type them as soon as they come to mind, and we will answer when we get to that section. I'll hand over to you now, Rory.
Thank you for this introduction, KJ, and welcome all. I saw you didn't mention one particular certification, KJ, which is Certified Ethical Hacker, and that is very key and important because we are ethical. For this agenda, so today we'll be covering shifting security left, and I'll be speaking about it. I'll be providing examples. We're going to be walking through the different stages of the traditional waterfall approach, and we're also going to be walking through the new and agile approach. So we're going to be touching into DevSecOps, some of the obstacles we typically face in DevSecOps. And of course, we have to speak about the benefits. We'll be providing some tips and recommendations around DevSecOps. And we have a pretty nice demo. So we're going to be demonstrating some of our capabilities in pen testing and how we leverage those capabilities during our DevSecOps opportunities. So before we start building or architecting any solution, and before we write any line of code to deploy any technology that supports your business strategy, you should have already considered security. And that is one of the principles of DevSecOps. So DevSecOps is a development practice that integrates security initiatives at every stage of the software improvement relationship between the development and the operations team. So it tends to try to break down the silo. So instead of operating in individual mindsets, we focus on building security into the process. And if you look on the diagram, you'll see that we have the development team and we have the operation teams, which is a typical way of operating. However, security is always considered after. And what we tend to do with DevSecOps is to shift security to the left. And in shifting security to the left, what that simply means is that it's a practice of moving security as early as possible. And it is conducted as a part of the shift left process, referring to moving security and any other security activities earlier in the delivery process. Ultimately, as I said, shifting left, ultimately, the goal of shift left is to avoid any critical bugs, any security defects during the deployment phase. So instead of identifying security weaknesses in the later stage, when you're trying to deploy, when you're trying to push your application or your systems to production, which it will be costly, and I'm going to show you some stats about that, it is always best to consider security as early as possible. So let's take a look at the waterfall model. And the waterfall model, it's very traditional. So it has been around for decades. And this model focuses more on a cascade style. It is a one-way flow, meaning it starts left. We have to complete our business requirements before we move on to the technical design. We have to complete development before we even start considering testing. And this approach, because it is so iterative and step-by-step, it may be time-consuming. So some of the concerns about waterfall approach with security is that security is not considered in all of the stages. So here we highlighted two main stages where we typically consider security, and it's during the technical design stage. So whenever we are looking at a system, we would look at the architecture, we would do a data flow diagram, we would do a threat modeling. And these are conceptually looking at the application to ensure that security is considered. But after the technical design, then the development team would go ahead and code. They may be coding for months, sometimes even years. And imagine the developers coding, building a software, building a system for months. And then we, the security team, comes in and starting to test that application months after. If we identify a security weakness or a security vulnerability or a flaw at this point in stage, we don't know what the developers are up to now. They may be going on to a different project. They may be working on somewhere else. And if we identify a security issue at this late stage, then it's going to be difficult for us to start back over the process and for the developers to correct the issue. Maybe you would possibly miss your go live time. So security tends to be periodic, and there's what's called a security checkpoint within the different phases, versus what we recommend to be a continuous process, meaning security is considered right across the life cycle. So business requirements, security would be there. We would provide security requirements. And this is what DevSecOps tends to do. Another drawback with the waterfall model is that it can be long, time consuming. And because we're working on particular or specific requirements, it is not flexible in us making any change. With the waterfall model, let's say the company wanted to add a new feature. It would be very difficult for them to add that new feature and continue the development path. So it's almost a rigid structure. And once you start embedding security in it, the approach gets very difficult. So it's a point of contention seen as slowing down the development process. And we don't want security to be viewed as such, because security is helping the process, ensuring that we are secure, because we don't want to build an application or a system that only focuses on the features and the functionality. It still has to be secure and safe. All right, so let's take a look at the results. And majority of us stated that security is actually considered during planning, which is 47% of us. And then 24% said design. I think that is very impressive if we're able to consider security so early. Majority of organizations, we see that they don't typically consider security that early in the life cycle. And a review that was done by Ernst & Young, Global Information Security Survey in 2021, they identified that security is considered in new business initiatives at the planning stage. Only 19% of companies actually consider it here. What is alarming to me is that the year before, in 2020, we saw that 36% considered security in the planning stages, and then in 2021, it actually reduced. Remember, one of the main reasons of DevSecOps is that we want to consider security as early as possible during the development lifecycle. So yes, it's good to do it in the design and all the other stages, but if we can start by considering security during the planning stage or the planning phases, that will be setting us up for a strong security foundation. So let's speak some more about the security building in the agile lifecycle. So one of the first steps, and as I just stated it, is that our requirements and design stage. So this is where we start. And when we start at the initial stages, some of the first things that we typically do is we have an initial review. So we try to understand how the security team, how will we work with the development team? And in doing that, we try to gain an understanding of what's the purpose of the application. Why are you building this application? What market are we building it for? Who are the users? How will they utilize the application? How will they utilize the system? It's very important for us to understand the context of the application, for us to properly test it, and to also provide good security requirements. We also need to understand the technical environment in terms of the application development and deployment policy. Do you have any processes and procedures in place? So once we have this foundation, then we will be able to properly align the security controls, security recommendations, and best practices to your environment. So what's next in the process? We tend to focus on security user stories. And what a security user story is trying to bypass the regular feature sets or function of the application. So in the agile approach, we would have what's called user stories, which a user story would say that this is the feature, this is what we're trying to build for this sprint or for this run, meaning in a 1 week iteration, we're trying to add this feature to the application. If you're trying to add this feature to the application, we would create security misuse stories or EVA stories, meaning a feature may be, how can I log into the application? Yes, you may have a username and password. As a security misuse story, we're going to challenge that and say, how can I bypass the authentication? Do I actually need a username and password to log in? Do I need my correct password to log in using my username? These are some of the tests that we would try. And this is why it's important for us to understand the features of the application and how it actually functions. Then we'll provide the developers with checklists. We'll provide them with guidelines. So we don't just provide them with training. Yes, training is a part of it also, but we also provide them with a checklist. And this checklist may include different tests and different ways of building the application to ensure that they're following secure coding standards, secure coding guidelines. If they're building in Java, for example, we would provide them with a policy that states these are the processes, these are the functions that you should use or recommended functions. This is how you should securely code. This is how you should leave comments in the code. Don't expose too much information. And even a part of our training, we provide real life examples of what should be conducted. How should you process? How should you develop an application? Typically, we use the OWASP framework, which is the Open Web Application Security Project. And that provides top 10 vulnerabilities or security weaknesses that you should protect your applications for. Typically, the training is also iterative. Sometimes we do training in lunchtime. So it's very flexible, very, very intimate, and it's a good way to convey security. And I can't stress training anymore because training is very important for the overall process. So then we move into the design stage. And with the design stage, we start by looking at the data flow diagram. And in doing the data flow diagram, this helps us to understand how data moves across the application. Where does data reside? What type of data is flowing through the system? And especially in this time pertaining to data privacy and data security, this is very important for the function of the application. Then we start to create what's called a threat model. And the threat model is using that data flow to understand and to map out and to recreate the process flow of the data. Typically, when we do a threat modeling, we utilize a model from Microsoft that's called STRIDE. And STRIDE stands for the S is for spoofing, the T is for tampering, the R is for repudiation, the I is for information disclosure, the D is for denial of service, and the E is for escalation of privilege. And using this framework, we're able to map out the different areas, the different controls that should be built into the system. And we're able to, from a conceptual perspective, state if there's any security concerns. And once we have the architecture in place, then we would test those controls further down in the process. After the design stage, then development would start. And while development is going, we would be looking at the code that the developers are building. So we don't wait until all the code has been written for us to take a look at the code. We actually, real time, we can look at the code, we do static code analysis. So any type of code that is being written, we look at it from a security perspective. We also encourage developers to utilize automated tools to scan their code while they're creating the code for the application. So they can install tools in their development environment, in their development library, that would also ensure that they're practicing good security controls while they're writing the code. Then we look on dependency analysis, and this can also be termed software composition analysis. And in simple terms, it's looking on the software libraries, the components that are being used when a developer is building an application. So they may be pulling from different libraries. We want to ensure that these libraries are secure. These libraries are up to date. We don't want to be coding with an unsupported library. After the development, then we move on to more testing. And in this level of testing, we're doing dynamic security testing. With dynamic security testing, it is looking on a runnable version of the code of the application, meaning that the application is functional. We can utilize the application, we can log into the application, we can walk through the application. We're looking at the business logic, we're looking at the APIs, the application program interface. We're looking on all the interaction points of the application. And further down in our demo, I'm going to be demonstrating how we utilize some of our security tools to do the dynamic security testing. After that level of testing comes more testing again. So the penetration testing is a bit different, because with the penetration test that we do, the application is now deployed in a staging environment. And in this staging environment, you would have additional security controls that the company or the organization would instill. So for example, they may employ a firewall, a web application firewall. They may employ server hardening. They may apply different patches to the environment or to the infrastructure. And we test the application in this stage because it should be a replica of what is in production. So you can see that there's multiple layers of security testing. And again, we use a mixture of automated and manual techniques and manual tools to conduct our testing. While the deployment is done, and once it's in the production state, we would also do vulnerability management and patching, and we would also monitor it in the production stage to ensure that there is no attacks conducted against the application. If there are attacks, we're able to see that in the logs, and we also produce and provide security testing in this real life and real world state. And again, It's a rinse and repeat process. So what I just explained may be a week or 2 weeks worth of testing, because in the DevSecOps space, we break down all the features and all the functionalities using the agile methodology, where we're trying to deploy small feature sets of the application continuously. So instead of waiting months to deploy or to build the application with all the features, why not deploy it piece by piece? So every week you may deploy a new feature, and that's the process. And that is why the DevSecOps and the Agile approach is recommended, and it also can consider security right across the entire life cycle. So what are some of the overall benefits of adopting DevSecOps? So it is faster, it's more efficient. It does provide and allow you to create an application, create feature sets faster. And because we are working alongside the development team, the operation team, and the security, we're not working in silos, we're better able to provide a higher quality and a faster software. We're able to spot issues, bugs, vulnerabilities earlier in the process. So because security is considered right across the board, we are able to identify security items from requirements, from the design stage, from coding stages, versus identifying it when you're going to deploy into the production state. There are more secure code bases that we recommend and that we can utilize. And because we're automating the process, we're providing cutting edge tools, we're recommending using these different tool sets and also supplementing that with the manual expertise from our team. It does provide you a more advanced security and a more robust way of looking on the overall application. And it is agile, so it is more flexible. So we tend to evolve and we tend to pivot. If we identify a security issue or a security weakness, we have a better way of managing that and a better way of controlling the risk. It provides continuous feedback and faster security vulnerability patching, because we're built in and we're integrating with the operation side. So if we identify a security issue to say that you have an outdated software version, then because we're communicating with the operations team and they're a part of the process, it's easier for them to patch. It's easier for the developers to communicate what version they need, and it is much safer and much faster. It's highly automated. So from a security perspective, we're able to leverage different tool sets. We're also able to script and to write common tests that we can run automatically. We can run it periodically. So for example, if we are logging into the system, we can have a script that automatically logs us in and tests certain parameters each time the application is done. So instead of us manually trying to brute force or manually trying to enumerate username and password each time, we can automate this process. It also provides us with continuous integration and continuous deployment or delivery in terms of continuously thinking about the end user, thinking about the customer, and continuously integrating and working together. So collaboration is very important. And it does offer a decreased time to market, meaning we can get more feature sets out faster. It takes a quicker time for us to deploy. So instead of having developers working 3 months, 6 months on one product, we can deploy to the market using a minimal viable product within a few weeks. And then we can continue building on that and releasing new feature sets. So everything isn't all good and great with DevSecOps. There are some obstacles that we have encountered. And unfortunately, most organizations tell us that their developers are inadequately trained in application security and secure coding practices. So most developers, they don't have adequate security training. And we typically recommend that we start with the minimum viable security whenever we recommended DevSecOps. And that could be simply just starting to provide security training. So based on a survey that was done, and it identified that 58% said that lack of skills is a significant hurdle in embedding security into their environment. And I do agree, because if we do not have the skill set, if we do not have the strong foundation from a security perspective, then it will be difficult for them to code security, for them to understand the risk around it. And then this one is even more alarming. 76% of university educated developers did not require any type of security training for them to complete their degree. I remember even when I completed my degree, I did one security course, and that was an elective. So it wasn't mandated. It was an elective course, computer security. And we need to change that mindset. We need to ensure that from in universities, from high school, from as early as possible, we need to start training and providing security courses, security experience and knowledge towards developers, towards end users, towards anyone in IT, and even generally. And almost 70% of developers said that their employers do not provide them with adequate training in software security. So this is one of the items that we tend to fix when we're working alongside our team in the DevSecOps process, because we do provide different ways and different items in terms of training, and different ways to train the team is also very important. So instead of having a presentation or a PowerPoint all the time, we tend to do a practical training, have an environment, show them, okay, we identify this weaknesses within your code base. This is how it could be exploited. This is how you should fix it. So taking a more practical approach. And it tends to lean better for us to identify ways of improving their processes. So developers would not be making the same mistakes over and over again. Let's take a look at the results. All right, interesting. We have a tie. So we have 33% saying 30 times more expensive, and also 33% saying 50 times more expensive, and 16% said 15 times more expensive. All right, good. So let's take a look at the results. And it is actually 30 times more expensive when security issues are addressed at production versus the planning stage or the design stage. And what's also interesting is that even identifying a security issue at the coding stage, it's 5 times more expensive than identifying it during the design stage. So this is why we have to consider that shift left security is good not only for reducing cyber risk, but also from a cost perspective, it will save us money. Because imagine having a system in production and we identify a security vulnerability with it. The risk is so high, and also the cost to possibly fix that issue if you don't have proper processes in place may actually result in you have to taking down that system, having a maintenance window, meaning if it's a payment system, then customers may not be able to log in or to utilize that system. And how long may it take to fix it? It is timely, because you have to think about coding, you have to think about integration, you have to think about regression testing, you have to also think about user acceptance testing, and then to promote it back into production. So it is more expensive. And that is why we always try to identify vulnerabilities as early as possible. There are going to be cases where we identify zero-day vulnerabilities, meaning vulnerabilities that are just been created, and this would be impacted in the production space. But as best as possible, whenever we're coding, let us shift and try to control security as early as possible before we go to production. So some of the top 5 vulnerabilities that we identify, that is Symptai. So our threat intelligence team would have done an analysis around some of our reviews that would have conducted between 2020 and 2022. We took 200 of our different engagements that we would have conducted. And what we identified is that as ethical hackers, we are able to breach our client environment 42% of the time due to improperly configured devices and systems. And 42% of the time for improperly configured devices and systems is pretty significant. And when I say improperly configured devices and systems, simply put, it means having default settings, using default credentials. And this is very alarming, because we're still seeing entities utilizing default settings, default passwords, default management configuration, and it needs to stop. We have to reduce that risk, because we need to ensure that we have a minimum baseline of changing passwords, of hardening the system, of hardening the configuration settings, so we can reduce this risk factor. Then what was number 2 is ineffective patch management controls, meaning we're not properly patching our systems or our application, we're not properly updating them. We're waiting until months after to apply a security patch. We're waiting until years after. Sometimes we don't even have the process in place to identify that there's a new update or a new version of a system that's out for us to properly patch it. So in the simplest term, security was not properly considered in the SDLC, in the software development lifecycle process. So let's not only consider security in software development, we need to look at security as early as we can possibly start. So even outside of the software development, what else can we do to ensure that security is considered? We need to ensure that our employees are security trained. So the human aspect is important. The staff, the end users, even the customers, we have to ensure that we are providing them with security tips, security recommendations. We have to get a security culture in the space and ensure that everybody in the workforce is promoting the desired security behaviors that we want. If we don't build that culture in, then it will be difficult for us to truly have a strong sense of security. Because it doesn't matter how much technical controls that we implement, how much tools we put in place, how many security automation, if the end users at the end of the day is not practicing good security hygiene, then it's almost pointless, because you are going to have an end user that's still writing down their password, that's still putting sticky notes with their password on there, that's not updating their systems, and simply clicking on a link, clicking on a phishing link. Social engineering exercises are recommended. So we have to consider the human aspect at all elements in security, from regular training, social engineering exercises, security awareness training. These have to be built in, and it has to be continuous. So instead of looking on security as an annual or a once per year item or agenda, just to check off a box. So yes, it's good to do an annual pen test, but let's evolve and think about security as a continuous process. So daily, weekly, monthly scans, monthly checks, monthly pen testing, having continuous monitoring and tools in place, ensuring that our environment is properly configured, reviewing these settings continuously and periodically, having alerts in place to ensure that there are no settings that have been changed. So we can evolve in not just thinking about, yes, I know every year at this particular time, we're going to be doing a pen test, so I'm just going to harden my system for the pen testers that are coming in. No, we can't do that. So we have to evolve from that. And in not doing that, we can see some remnants of what can happen if we don't harden our systems. And it goes to say that even the security companies need to harden their system. Even we at Symptai, we have to test our system. We have to harden it, we have to patch it. So who guards the guards? And this is a perfect example of a situation where Cisco, as a vendor, as a security company, as providing IT tools, security tools, their anti-malware scanner was vulnerable to a serious security flaw. And that tool that they used, that clamp AV, was used to protect servers, protect email servers. So the tool that you're using to protect your email or your assets also had a vulnerability in it. And that's stemming from a security flaw in terms of how it was developed and built. Even patching. So we would have patched our systems, and the patch that we applied to our systems was also vulnerable. We even saw that GitHub, GitLab had security weaknesses based on an audit that was conducted. So it is imperative that we consider security continuously and right throughout the process. So it cannot be an afterthought, because we see day by day multiple different companies being impacted by this. And I'm going to be jumping into our demo. And what we're going to be discussing and what I'm going to be showing is one of our application security testing tools. So we're going to be using a tool called burp, and we're also going to be inspecting the application request and response. So when we look at an application, we don't just visit the website or visit the web page. We look beyond that. We look on the requests that are going to the server, the responses from the server, and that is how we inspect and look at all systems once we're testing them. We're also going to be doing some directory enumeration, meaning trying to identify different directories or paths that are associated with a website. And we're going to be exploiting a software vulnerability. So stay tuned for the next few minutes, and we're going to be off now. You're going to be seeing, I'm looking to my monitor to the right. So here, one of the first things that we do is we're going to be leveraging Nmap, and this is a tool that scans the different services or open ports on a IP address. Once we are able to identify that this is a valid IP address, we are then going to launch an application. So the port that we identified was 41062, and this is the tool burp. So burp is an intercepting proxy, meaning all the requests that are being sent and received from a website, we're able to intercept, and we're able to inspect, interrogate, we're able to try to launch malicious attacks against it. We're able to change how the server would respond or what is being sent to the server. So in this example, we visited the web page, and this is a XAMPP web page. It could be your website, it could be your WordPress website, your company website, it doesn't matter. But in this example, this is a technology that's used to build a web application. And here we're starting to inspect the application. So once we've visited the application, the website, we saw that this is the dashboard page that is brought back to us. And these are the requests. So this was a request that was sent, and this is a response on the right, meaning once the page is loaded, it provides you with a response. What we're doing now is that we want to identify if there's any other path on this application. So here we have dashboard, and what if there's a different path? What if there's an admin path? What if there's a separate website that's associated with this page? And so most of your website may have an admin panel. So here we're loading a list, and this list is what we're going to use to do the enumeration. So here you can see that there's different updates, uploads. These are different paths that we're trying to identify within the application. And then we're going to start the attack. And in this instance, the attack, we're looking at 372 different instances. Any status that shows us with a 200 will mean that it is valid. This means that it exists. And here we're able to see that IMG www CGI bin is not accessible. So let's take one of these paths, and we're going to take the www path, which is right here. And we're going to try to visit this path in the web application. So this is showing us that the application actually got a request, got a response. So let's just simply change the path. So change it from dashboard to www. And what we see is that there's actually a directory here which shows us additional information. So as an attacker, we're going to explore the directory, and we actually find that there's a different site. The site that's here is Right CMS, which is a content management system platform similar to WordPress, similar to Juno. And we're able to look at the source code, we're able to look at the information. But what is very interesting, and what we typically do, is looking at the version of the content management system. So if it was a WordPress, we would research a current version and see if there's any associated vulnerabilities with it. So in this instance, we're just going to be doing a Google search. And one of the resources that we use a lot is ExploitDB. So ExploitDB is a database that provides us with ways to exploit vulnerabilities that exist within the system. And there are multiple other databases that we use, but in this example, this is showing us that this is a remote code execution vulnerability, and it's going to show us how we can exploit this vulnerability. And these are the steps that we're going to be using. So step one, we need to log in as an admin. So either we can try to identify the admin credentials, we can either enumerate it, and in our demo, it's actually going to be a default credentials for the admin, then the next step is that we're going to go to the files manager. We're going to be uploading a remote shell. So let's log in, or let's try to log in. But where's the login path? And here we see that the login path, the default login path, is admin.php. So we're going to enter that into our URL and admin.php. It brings us to a next area of the web application. And username is admin and the password is admin. That's just default settings. If we did not know that the default password was being used, then we could take a similar approach to how we enumerated the directories. We could also try and enumerate the valid password that's associated with the application. So that could be automated also. If there's no lockout controls in place, then we could just have that running until we identify the valid password. And that is why it's important to use strong password throws. So here we're logged in as the admin. We're going to go to the files manager and we're going to upload the shell or the script that will allow us to get remote access to the server. So our end goal is that we don't want to only take over the website, but we want to take over the entire server. And by doing that, we're going to be using the same vulnerability. It provided an exploit using a shell. And this is the shell that we uploaded, c99shell.php. And now we need to execute that shell. So we can simply just click on the shell. And what we're going to do is change the path because the path is incorrect here. But this is another vulnerability or issue because it's the error message is displaying too much information about the application. So it's telling us the Apache version, it's telling us the OpenSSL version, the PHP version. We could also then do more research about if these versions has vulnerabilities. So for example, the PHP version here is 7.4.29. The latest PHP version is 8.2. So there are security vulnerabilities associated with it. So we change the path and now we're going to execute it. And like that, it has been exploited. So simple, we have owned the server. We have taken over the server. These are all the files that are listed on the server. And just to prove that we have full permission on the server, we're going to be able to run some commands on the server. So let's see ID. It shows us the user ID. We can list the different directories. We can even try and pull back user accounts or user passwords that are on this server. So right now we're using the daemon account of the application of the server. So let's list the directories. We're seeing other directories that we can actually go into, other files, all the information there. And just to show you one other thing, we can actually cat or view the password file and folder. So here we're going to see that we have, these are all the different accounts that are on the system. And we can use this access to do pretty much anything because we would have pretty much taken over the system. All right, that's it for the demo. And this is a regional use case that we have. So one of our companies, our clients that we actually work with providing DevSecOps service. So this is a blue chip company, conglomerate of companies that have operating in the Caribbean, in Europe, in North America, and they have banking, investment, insurance, all these different services that they offer. They had a business idea, and what they were going through is a digital transformation journey. And in going through this journey, what they wanted to do was to have a mobile application where they were able to have all the different services that they offer. So the banking service, the investment, the employee services, all of that in one central location using a mobile application. And how they did that is by using their core systems and through APIs. So we were able to provide security services during this development journey. And we were able to review the mobile application. So some of the benefits that we provided to them, and these are just some of them, we were able to provide security testing in the agile development process that they were providing. So instead of just having DevOps, we were able to implement and put the security in the DevSecOps. We provided threat and risk modeling development of data flow diagram, architecture review. Some of the security testing that we did included looking at the different websites that were associated, looking at different APIs, looking at the mobile application that they built, both Android and iOS, and we're able to even security test Windows application. And typically when we test these applications, we look for authentication, session management. We even looked at the business logic of the application. And this is where a lot of our manual testing comes into play, which is why I stated it's very important for us to understand what this application is going to be used for. We even did automated testing and looking at different codes that are being used and some of the deliverables that we provided to the client. So we did training. We did provide them with test results for each sprint. So each sprint in this instance would be every 2 weeks, they would try to build and release a system. And because we were integrated into the process, we were able to log our security issues into their ticketing system. So if they're using Jira, if they're using Confluence, there are different types of ticketing system that you can utilize. So we were able to operate as a part of that company, working alongside the team on a day-to-day basis, providing security oversight, recommending security tools, implementing security tools to build automation alongside the process. And at the end, we also provided them with a monthly report just to summarize all the security issues and findings that we would have identified. What was also very good and encouraging is that when we compared the security findings that we would have identified on a month-by-month basis. So for example, during the early stages, we would have found like 15 security vulnerabilities. Then we would have had the developer training, and over time, that amount would reduce. So developers would be learning to code more securely. And that would also challenge us to now think about different ways that we can actually provide penetration testing. And that is our presentation. So I think there's a few questions, and we do have about 10 minutes where we can take those questions. So KJ.
Yes, yes. They have been rolling in throughout the presentation, Rory. So let's address the ones we have in the chat. Okay, so I think this question would have come in when you were comparing when you were speaking about how to involve security earlier in the development cycle towards the beginning of the presentation. And the question is, this process seems to significantly lengthen the development cycle, which has implications on cost and agility. How do we keep an eye on development time while still keeping security in mind, which is a really, really good question.
Yeah, so it's always important that from a planning perspective, that's where we think about the different products and different features that we want to roll out. So when we start a project management is important. The agile approach, the overall project management approach that you're using is also important. If you're going to use agile, Kanban, there are so many different types. But when you compare it to the waterfall, the risk of identifying a security risk afterwards, after all of that development and all of that coding is done, the cost, as you see, it is much more significant versus having the agile approach in place, having project metrics in place. So you track, for example, like how much time you're spending on a project. And in how we approach DevSecOps, we only charge a client for the hours that we consume. So for example, on a month-by-month basis, if we're providing a DevSecOps, we may only be spending 100 hours on this engagement. So you would only get charged for the 100 hours. It's not a case where we are going to pay us for forever the same amount. So if we don't test anything or if we're not involved in a sprint, then you would not be charged for that sprint. So those are some ways that you can monitor how much it's going to cost and the spend, and also ensuring that security is built in. You can ensure that automation is also included in the process, which is a good way to balance the fact in terms of automation and also the overall cost.
Since we're on costs, someone did make the comment that isn't this a rolling cost? Isn't there a rolling cost associated with mismanagement as well? Also, it depends on the level of security fix that is needed, meaning if it's a hardware, software, physical infrastructure. I think the point is that First of all, how do we know the information that you presented saying it is X times the cost? Where did we get those figures from? So we have some investigators here joining us, want to know where that came from and how would we calculate it since it's a rolling cost?
Yeah, so that was done by a survey that was conducted by Ernst and Young. So they did a survey, they did their analysis about it. But an easy way for you to look on it is the return on investment. So look at the opportunity cost. So instead of you waiting a year to get a product or a feature out into the space that you could generate revenue from, versus you taking a month to get it out there where you can generate some revenue, which one would outweigh the cost? Is it that you want to wait a longer time to develop and build all the feature sets? And what if 8 months down the line, you think about a new feature, you see a new feature? If you're going to now be adding that feature, it may impact the entire 8 months that you took to build that system using the traditional approach. So that's a good way to look at it.
Okay, one more question. If development is happening platforms that offer their own security frameworks, is there a need to invest significantly DevSecOps, or is it okay to simply sensitize developers and business/process owners to security risks that cannot be avoided?
That's a very good question. And I would say, yes, it's still important to embed security, to embed security team in the DevSecOps process. So we have worked with teams that are global, that they work in different environments, that they have a fully built agile process in place. And when we start testing, we see security issues. We have had cases where even people thinking that just because they're moving to the cloud, their software is fully safe and fully secure. We have had cases where we have reviewed cloud security, cloud applications, and have identified security issues and weaknesses. So remember that it doesn't matter the level or the scale that you still have to consider security. It may not be as extensive as if you are building in-house, hosting all your systems in-house, versus shifting some of that risk to the cloud or shifting some of that risk to a third party. It's just a transfer of risk, but it's not eliminating the risk. So you still have to invest into DevSecOps. You still have to invest in security, because even some of our clients, we recommend them having automated process along the entire life cycle, but you still need someone to interpret those results. You still need the manual testers. So you still need us in that process and in that environment. So we have had cases where at every stage you have an automated tool, and I can list out so many different tools, and yet we're still able to identify security weaknesses. It could be simple as just a developer leaving a comment in a code that has credentials in it. But sometimes the tools can't pick that up. Sometimes the business logic testing that we do, the tools are unable to understand, okay, yes, the application is doing a transfer between A and B, and it's a multi-currency. Some of those things we have to test manually, and that's where the expertise comes into place. Yes.
Good point. Thank you for that, Rory. Let's race to the rest. Okay, can you elaborate on, well, first of all, morning, this is an excellent material being shared. And can you elaborate on which upskilling or certifications are currently mandatory for DevSecOps professionals?
All right, so I wouldn't use the term mandatory, but I would use recommended. So there's different types of certification and skills. Even outside of certifications, let's look at training first, because you have training that are on like Udemy, on all these different platforms. Even LinkedIn, you can find training specific to DevSecOps. What we recommend is any training that you're doing, ensure that it's aligned with one of the application security frameworks. So we typically recommend OWASP, so the OWASP top 10. Any type of training should be aligned with that. From a certification perspective, there are different security certs that are important for a strong foundation. So for example, your Security Plus, you may want to have your ethical hacking courses. Then you may want to get a little more advanced into like your OSCP, so offensive security, your CSSLP, so your secure software security lifecycle professional. These are different certifications. What we tend to do in Symptai is that we have a training plan and a training path that identifies a strong core and foundation, and then we build on that foundation for the specialization, because DevSecOps is a specialized area. Application security is a specialized area. Infrastructure security is specialized. So if we're doing DevSecOps, let's say in a Microsoft environment, it's a bit different from us doing it in an AWS environment. So we need a team member that has a AZ500 training, for example, or AZ500, focusing on security in the DevOps pipeline in the Microsoft space versus in AWS.
Understood. All right, we have 3 more questions, Rory. I'm mindful for the persons who may need to hop off. Can you just go to the next slide so they can see the QR code and scan that to connect with us on LinkedIn, as well as they can see our contact information, just so we can continue the conversation after this for those who have to hop off. We're also going to ask that you complete the survey. Please, please, please. It's just a few questions if you do have to hop off exactly on the hour. But let's tackle one more question. Is DevSecOps the same thing as Red Team? And are there any specific frameworks for DevSecOps? So that's 2 separate questions. I'm just throwing both of them at you.
All right, so DevSecOps is different from Red Teaming. So the main difference is that Red Teaming, and we do Red Team engagements also. So Red Teaming is doing pen testing, but using any particular approach possible to try to break into your network or try to bypass your controls. So for example, we may use social engineering, we may do a pen test, we may drop a flash drive physically into a space to let someone plug it into their environment. So the end goal is a bit different. It's testing the security posture of your organization to see what are the possible ways that an attacker can break into the overall network. While DevSecOps is focusing on, while you're building an application, where you're building a system, so it's focused more on the application development lifecycle and embedding security into it. But we do use some of the tools and some of the pen testing approaches during the DevSecOps.
Gotcha. The question about specific frameworks. Are there any specific frameworks for DevSecOps?
There's a few frameworks, but we at Symptai, we pretty much take a hybrid approach where we combine multiple frameworks. We leverage different application security frameworks. So for example, OWASP is one of the primary ones that we leverage. So we use what's called the OWASP ASVS, so the Application Security Verification Standard. And then we also leverage like the SANS Top 25. So it's a big combination, and we take the hybrid approach because every environment is different. So we have different clients that we use different approaches and different methodology based on how their environment is set up for the DevSecOps. And we find that that approach is a bit better, and you get a broader coverage.
Sounds like you need to give us a call, Rory. Let me just shoot the next 2 at you.
I'm
an outsourcing development. If I am outsourcing development, or purchasing applications from a vendor, how would I approach DevSecOps? That's one question. And then the final one is, does Symptai support software development companies by embedding security pros as a service? Definitely yes to the last question. So you can answer the one before.
Yes, definitely yes for the last one, for true. In terms of outsourcing development, that one is easier, because if you're outsourcing development, which we have worked with a company that outsourced their development, and we're able to integrate into that team that outsources the development. If you're purchasing an application from a vendor, it's much more difficult for us to build DevSecOps into the process. We have a different service that we offer, which would be software evaluation. We also offer application pen testing as a service there, and we can also provide like recommendation with requirements. So we have worked with quite a bit of our clients that are looking to purchase applications, and we're on the call, we're on the discussion, we're sitting in the demos, we're providing the security requirements that we expect the company to build the application against. We are also evaluating the application from a security perspective before they implement it in the environment. And we have had cases where we have identified security vulnerabilities, and we have set the baseline to say that this must be fixed before it is implemented into the client space.
Exactly. So involve Symptai in the process as early as possible.
As early as possible.
As well. Roy, do you have any final words before we sign out?
Yes, so definitely ensure that security is considered at all stages. And as we stated, not only in the software development lifecycle, but you can even look outside of that. How your company operates, how you operate, ensure that you are practicing good security controls. Simple things as updating your phones, updating your laptop, not writing down your passwords, ensuring that you have security tools in place, and I can continue listing examples. But it takes a good security culture for everybody to play that role to ensure that they're safe and they're secure. Even your children, you need to recommend that to them. You need to practice certain good control, because we have seen cases where kids have installed an application on the phone, which is a malware, and the company device ends up getting compromised. So it's important to consider security right across the board, not only in software development, but it has to be considered right across. And you can definitely contact us, because we do offer a wide range of security services and tools.
Thank you again, everybody, for joining us. We're going to let you go. Have a fantastic day. Please contact us. We can continue the conversation. We have a lot to offer the conversation when it comes to integrating security at all levels and in the whole process for your organization. Signing out, everybody. Thank you so much again. Have a wonderful day.
Thank you all. Bye.